1 gram of steam at 100 degrees centigrade and 4 gram of ice at 0 degrees centigrade are mixed in a thermally insulated container. The final temperature of the mixture is close to latent heat of fusion and vaporization of water, or 336 and 2268 joule per gram respectively. Here steam releases heat and ice absorbs heat. So the Q released by Q out by steam, Q out of steam is equal to Q in of ice. So the heat released by the steam is equal to heat absorbed by the ice. So what is the amount of heat released by this steam? Suppose if you take steam first converts into water, steam at 100 degrees centigrade, this one converts into water at 100 degrees centigrade, and this one converts into water at some T degree centigrade. Suppose if we take ice at 0 degree centigrade, this one converts into water at 0 degree centigrade, and this one converts into water at some T degree centigrade. So you have to calculate how much amount of heat released by the steam and how much amount of ice released, how much amount of ice absorbed by the ice. So here Q out of steam, it will be equal to M1 L1 plus M1 S delta T is equal to M2 L2 plus M2 S delta T. Here M1 is the mass of the steam and L1 is the latent heat of vaporization, and S is the heat capacity of water, and M2 mass of the ice, and L2 is latent heat of fusion, and delta T change in temperature. Delta T1, let us take delta T2. Here M1, what is the mass? 1 gram, and L1, what is the L1? Latent heat of vaporization is 2268 plus M1S 1 into S is 4.18 in joules, 4.18 in calories, it is 1 calorie, and delta T 100 minus T is equal to, what is M2? 4 grams, 4 into, and 336 plus 4 into 4.18 into, what is the temperature difference? It is T minus 0. T minus 0. This is the temperature of water and temperature of ice. When you solve this equation, you will get T is equal to around 64 degree centigrade. Okay, this is the correct option. 100 gram of benzene is mixed with 100 gram of toluene at 20 degrees centigrade and 1 atmosphere. Assuming ideal behavior, the entropy of mixing is. Here we know that the entropy of mixing, delta S mix, is equal to minus NR sigma Xi ln Xi. Here two components are there. One is 100 gram of benzene and 100 gram of toluene. One is benzene, another one is toluene. This one is 100 grams and this one also 100 grams. Then what is the molecular weight of benzene and toluene? Okay, benzene C6H6, it's a 78 grams. C6H6, 78. and this one is C6H5CH3. You have to add 40. It will be equal to 92. So when you divide with 78, you are getting number of moles of benzene and also number of moles of toluene when you divide with 92. Okay, you will get roughly you will get 1.282. This one is 1.087, and the total number of moles will be 2.369. Then what is the mole fraction, Xb and Xt? Mole fraction will be 1.282 by 2.369. This one Xt 1.087 by total number of moles 2.369. You will get 0.5411 and 0.4589. 0.4589. For this you have to use calculator. Then delta S mix is equal to minus NR. It's a 2.369 into R. Okay, it is in terms of calories. You can use 1.98 or simply you can write 2. And sigma xi ln xi, first you have to take benzene. What is the xi value? 0.5411 ln 0.5411 plus, and the next one 0.4589 ln 0.4589. So finally you will get, after calculation, you will get, it will be equal to around 3.24 calorie Kelvin. You will get. This is the correct option. Which of the following statements is always true for a reaction in which there is only expansion work? Okay, according to first law of thermodynamics, delta U is equal to Q plus W. Okay, when there is only expansion work, Q is equal to 0 and W is equal to minus P delta V. So you can write delta U is equal to minus P delta V, and delta U plus P delta V is equal to 0. Suppose when pressure is constant, P is constant, delta U delta E into PV is equal to 0. Okay, this one when P is constant. Okay, you can bring this P here. Then delta of U plus PV is equal to 0. So what is U plus PV? H. Delta H is equal to 0. So only expansion work, which one is correct? Delta H is equal to 0. A perfect gas expands reversibly at a constant temperature of 298 Kelvin so that its volume doubles. What is the change in the molar internal energy of the gas? It's a perfect ideal gas, reversibly at a constant temperature. At constant temperature, the change in internal energy is equal to 0. Okay, this one for ideal gas, and delta T is equal to 0. So this is the hint: at constant temperature and perfect gas. What is the molar internal change in molar internal energy of the gas? This one is 0 joule for molar mass. The Joule-Thomson process is a isoenthalpic process. The change in enthalpy, delta H is 0. We know the Joule-Thomson process. It's an adiabatic process. There is an expansion of gas from high pressure to low pressure. In this condition, the change in enthalpy is 0. The standard enthalpy of vaporization of water at its normal boiling point is 40.7 kJ per mole. The entropy and internal energy change are respectively. What is the change in Entropy. Okay, entropy is delta H by T, simply delta H by T, 40.7 kilojoules. Entropy is given in joules, so you have to convert into kilojoules into joules by multiplying with 10 cube, divided by what is the temperature, 100 degrees centigrade. So you have to take in Kelvin, 100 plus 273, it's 373 Kelvin. 373 Kelvin. So you will get 40700 by 373. So around you will get 109 joule Kelvin mole. And what is the internal energy change? What is the internal energy change? Delta H is equal to delta U plus delta Ng RT. So this is the equation. Then delta U is equal to delta H minus delta Ng RT. Here the vaporization of water. Suppose H2O liquid converts into H2O gas. So what is the delta Ng? Delta Ng, the number of gaseous molecules on product side 1 minus reactant side 0, so it's 1. So delta U is equal to delta H minus Ng RT means delta Ng positive plus 1, so delta H minus RT. What is the delta H value? 40.7. So delta U is equal to 40.7 kilojoule mole minus R. What is the R value? You have to take 8.314 in joules, and the temperature it's 373. If you want to convert the joules into kilojoules, you have to divide with 10 cube. 3 by 10 cube. This one equal to 40.7 minus 3.1, 37.6. So this one is the correct option. What will be the molar mass of an ideal gas if the specific heats at constant volume and at constant pressures are 0.015 and 0.025 calories gram degree centigrade respectively? We know the relation between Cp and Cv. Cp minus Cv is equal to R. What is the Cp value at constant volume? Cp and Cv. These are given in calories grams degree centigrade. This is Cv 0.015. This is in terms of grams 0.025. This is also in terms of grams. But you have to take molar heat capacity at constant volume and pressure. So you have to multiply with the molar mass. Let us take molar mass. Molar mass is M, let us take. Then you have to multiply with M, 0.025 M molar heat capacity, 0.015 M molar heat capacity. Then what is the relation? Cp minus Cv is equal to R, means 0.025 M minus 0.015 M is equal to R. What is the value R? 1.98. In calories 1.98. Then M is equal to M 0.025 minus 0.015, 1.98, or you can write 2, around 2 you can write, and this one is equal to 0.01. So M into 0.01 is equal to 2. So M is equal to 2 by 0.01. It will be equal to 200. What is the molar mass? 200 gram per mole. If delta G naught is positive for a reaction, the value of K is. What is the relation between delta G naught and K? Delta G naught is equal to minus nRT ln K. Or you can write minus 2.303 nRT log K base 10. Suppose less than 0, K less than 0. Here k less than 0, it's not possible. Equal to 0, suppose log k equal to 0, you will get 1. Greater than 1, you will get negative value. Suppose if k greater than 1, what is the value you will get? This term will be positive. When k greater than 1, log k positive, so the whole term will be negative. Suppose if the value in between 0 to 1, 0 to 1, let us take k is in between 0 to 1, then this value log k will be less than 0, means it's a negative term, negative of negative, it will become positive. So when the k value is between 0 to 1, 0 to 1, 0 to 1, delta G positive, and greater than 1, delta G negative, and is equal to 1, delta G is 0. These are the important relations. When k is in between 0 to 1, positive, delta G, greater than 1, delta G negative, and is equal to 1, delta G 0. For combustion of benzene in a sealed container having rigid thermally conducting walls, that is immersed in a water bath at 25 degrees centigrade. Here, having rigid thermally conducting walls. Rigid walls means there is no expansion. So delta V is equal to 0. When delta V is equal to 0, W is equal to 0. So these two are incorrect. And for combustion of benzene in a sealed container having rigid thermally conducting walls, that is immersed in a water bath at 25 degrees centigrade. So there is a transfer of heat from this container system to water bath. So when there is a transfer of heat from this system to water bath surroundings, there is a decrease in Q value and also decrease in um, internal energy. So which one is the correct? W is equal to 0, Q less than 0, delta U less than 0. This one is the correct option. Which of the following is necessary for a process to be spontaneous? Okay. According to second law of thermodynamics, the process is spontaneous when delta S system and delta S surroundings greater than 0. Means delta S universe greater than 0. In universe, there is a continuous increase in entropy according to second law of thermodynamics. Okay, this one is incorrect, this one is incorrect, this is correct one. Delta S universe should be greater than 0. Which of the following information will be necessary to calculate the change in entropy of a reversible process? A change in entropy, reversible process. Which one is needed? There is a need of temperature. We know that delta S is equal to delta H by T. In reversible process, to calculate change in entropy, you have to know the temperature. In thermodynamics, a property is called extensive if its value is additive. Which of the following is not extensive property? The extensive property depends on mass, size and volume of the matter. So mass is extensive property, volume is extensive property, heat capacity, it's not extensive, it is also extensive property, sorry, and specific heat, it's intensive property. When there is a specific or molar terms, it will become intensive property. Predict the sign of delta S for both the following processes. Okay, graphite is converted into CO2. The number of gas molecules on right side 1 and here 2 moles, means delta Mg positive. So delta S increases. When more number of gas molecules on product side, there is an increase in delta S. And gas is converted into liquid, so delta S decreases. Delta S less than 0. Delta S should be negative for first one. Delta S should be negative. Delta S should be positive. For first one, delta S should be positive. and second one negative. This is the correct answer. Delta S should be positive for first one and negative for second one. The entropy change associated with the expansion of 1 mole of an ideal gas from an initial volume of V to final volume 0.2.50 V at constant temperature. Okay, what is the delta S? Delta S is equal to NR ln V2 by V1. NR, number of moles, let us take 1 mole of an ideal gas. So 1 R ln V2. What is the V2? This is a V2 and this is a V1. 2.50 V by V, there is a cancellation of V. So you will get delta S is equal to R ln 2.50. Which of the following statements must be true for the entropy of a pure solid to be 0? According to third law of thermodynamics, perfect crystalline or perfect crystalline substance, you can take any substance, it should be perfect, means that there is no imperfections, there is no disorders, or there is no defects, and a crystalline substance at 0 Kelvin temperature, the entropy is 0. This is a statement of third law of thermodynamics. The temperature must be 0 Kelvin, correct? The solid must be crystalline, not amorphous, correct? The solid must be perfectly ordered. Perfect means there is no imperfections. The solid must be an element, need not be. The solid may be an element, the solid must be an element, need not be, correct, need not be. So this one is wrong. So what is the correct? 1, 2 and 3. For any substance at 0 Kelvin, crystalline, perfect, solid, the entropy is 0. This is the statement of third law of thermodynamics. So this one is the correct one. An ideal gas undergoes isothermal and reversible expansion from its initial volume to some final volume at 300 Kelvin, drawing in 90 kJ of heat. The change in the Gibbs free energy of the gas is. In any reversible process, a reversible expansion or compression process, for reversible process, the delta G is equal to 0. So what is the change in Gibbs free energy? It's 0 joules. An extensive property of thermodynamic system among the following is. Extensive property, this one depends on its additive property. It depends on mass, volume and size of the matter, size of the system. Pressure, it is independent of mass, volume or size. So this one is intensive. Temperature, intensive. And also concentration, all concentration terms are intensive properties. If you take 1 ml solution or 1 liter solution, there is no change in concentration of 1 molar solution. If you take 1 molar solution of 1 ml or 1 liter, there is no change in concentration. But volume, it's a extensive property. So which one is the extensive property? Volume is the extensive property. Application of the condition of exactness of the differential dE is equal to TdS minus PdV leads to. Okay, Maxwell's relations. How can you get Maxwell relation from this equation? TdS minus PdV. First, to differentiate the term T with V. Okay, dou T by dou V at constant S. This is constant. You have to put constant this one. And this one is negative. And for this, you have to differentiate with ds, dou P by dou S at constant volume. From this equation, you can get this relation. Dou T by dou V. You have to differentiate T with V first. Dou T by dou V at constant S is equal to dou P by dou S at constant V. Here negative sign, you have to put the negative sign. So what is the relation? Dou T by dou V at constant S is equal to minus dou P by dou S at constant V. This is a Maxwell relation you can get from this equation. 1 mole of an ideal gas expands isothermally from 1 liter to 10 liters at 300 Kelvin. The work done by the gas is, W is equal to 2.303 minus 2.303 nRT log V2 by V1. Here minus 2.303, number of moles 1 mole, and this one is in joules. You have to take 8.314 into temperature 300 Kelvin, 300 into log V2 by V1. What is the V2? 10 liters and 1 liter, 10 by 1. So this one is 1, log 10, 1. So when you multiply these, you will get around 5757 joules. This is the work done by the gas. Consider the three processes: sublimation of solid, cooling a sample of cobalt solid from 60 degrees centigrade to 25 degrees centigrade, and the combustion of charcoal to form CO2 and H2O gas. The signs of delta H and delta S for the processes. Sublimation, solid converts into gas, so it needs temperature. So delta H is positive, delta S is positive, delta H, delta S positive. Okay, this one delta H positive and delta S positive. And second one, cooling, delta S obviously negative, and in cooling there is a release of heat, delta H negative. And next one is combustion process, always delta H negative, and here there is a release of gases, so delta S positive. So which one is correct one? First, bromine has a heat of vaporization of 30.91 kilojoule mole inverse, and its boiling point is 59 degrees centigrade. What is the entropy of vaporization of bromine? Delta H vaporization is given. It's a endothermic 30.91 plus 30.91 kilojoule mole inverse. When you convert into joules, it will be 30.91 into 1000, 10 cube joule mole inverse. And what is delta S vaporization? Delta S vaporization is simply delta H vaporization per unit temperature by temperature. Here T is 59 degrees centigrade. You have to convert into Kelvin. 273, it will be 12, 630 and 332. So you have to divide delta H by T, 3910 by 332. Around you will get 93.1 joule mole inverse Kelvin inverse. Here the plus value you will get. Thank you very much.